Welcome to Unit 2, Lesson 21, Graphing Linear Inequalities in Two Variables, Part 1. Our learning goal today is to find out how to use graphs to represent solutions to inequalities in two variables. We have two learning targets today. Learning target number 1 is that by the end of the lesson, you feel comfortable saying, given a two-variable inequality and the graph of the related equation, I can determine which side of the line the solutions to the inequality will fall. So unlike the first half of Unit 2, where we were only graphing the line of the equation, now we will be graphing the line and one side of the line or the other will contain the range of solution answers. Learning target number 2 is that by the end of the lesson, you feel comfortable saying, I can describe the graph that represents the solutions to a linear inequality in two variables. So you need to feel comfortable describing whether we are including the line that acts as a boundary or whether we are not including the line. And you need to feel comfortable describing which area of the graph contains the solutions. Our first practice problem says here is a graph of the equation 2y minus x equals 1. And question number 1 wants to know, are the points 0, 1/2, and -7, -3 solutions to the equation? So in order for the points to be solutions to the equation, there are two ways to check. The first way is graphically. They would need to be on the line. So if we go to 0, 1/2, that does appear to be this point right here on the line. Next, we can go to -7, -3, and that also does appear to be this point right here on the line. Now, because they are in areas that are not right on crosshairs, we may want to go ahead and check algebraically as well. So first we would say 2y, and y is 1/2, minus x, and x is 0, equals 1. Well, the 2's cancel each other out, and we have 1 minus 0, which equals 1. So that is true. So yes, 0, 1/2. Now let's check the other. We would have 2 times y, which would be -3, minus x, which would be -7. 2 times -3 is -6, minus a negative 7 becomes plus 7, and negative 6 plus 7 does equal 1. So yes, 0, 1/2 and negative 7, negative 3 are solutions. And we showed that graphically because the points are on the line, and we showed that algebraically by substituting them into the original equation. Now, number 2, check if each of these points is a solution to the inequality 2y minus x is greater than 1. So let's try some of these. We would have 2 times y, which is 2, minus x, which is 0. 2 times 2 is 4. Minus 0 would just still remain 4. And 4 is greater than 1. So 0, 2 is a solution. And we could find that at 0, 2. This point right up here. Now let's check the next one. 2 times y, which is 1/2, minus x, which is 8. 2 times 1/2 is 1. And 1 minus 8 is negative 7. Negative 7 is not greater than 1, so 8 and 1/2 is not a solution. The next one, we would have 2 times y, which is 3, minus x, which is negative 6. 2 times 3 is 6. Minus negative 6 would be plus 6, which equals 12, and that is greater than 1. So this would be a solution. So we can go to negative 6, positive 3, and put that point right there. And the last one we could check, 2 times y, which is negative 3, minus x, which is negative 7. 2 times negative 3 is negative 6. Minus negative 7 becomes plus 7. Negative 6 plus 7 is 1, and 1 is not greater than 1, so that is not a solution. Number 3 says shade the region that represents the solution set to the inequality 2y minus x is greater than 1. Well, we can see that the points that worked were 2 points above the line. That means the entire area above the line is going to be solutions to the inequality. And finally, number 4 asks, are the points on the line included in the solution set? Explain how you know. And the answer is no, because the points on the line make 2y minus x equal 1, and we only want the points that make 2y minus x greater than 1. If you have any questions about how to solve this practice problem, please use class time to ask for further clarification before we move forward. Our next practice problem says select all coordinate pairs that are solutions to the inequality 5x plus 9y is less than 45. Notice that it says select all. That means we need to check every possible answer to see if it's correct, because there can be more than one correct answer. All we need to do is take each point pair, substitute the first number in for x and the second number in for y. So A says 5 times 0 plus 9 times 0 should be less than 45. Well, 5 times 0 is 0, 9 times 0 is 0, and 0 plus 0 is 0. 0 is less than 45, so A is a coordinate pair that is a solution to the inequality. On B, we have 5 times x, which is 5, plus 9 times y, which is 0, and that should be less than 45. Well, 5 times 5 is 25, 9 times 0 is 0, and 25 plus 0 is just 25. That is less than 45, so B is also a point pair solution to the inequality. Now let's check C. This would be 5 times x, which is 9, plus 9 times y, which is 0, and that should be less than 45. Well, 5 times 9 is 45, 9 times 0 is 0, and 45 plus 0 is 45. And 45 is not less than 45. So C is not a solution to the inequality. Now we look at D. 5 times x, which is 0, plus 9 times y, which is 5, should be less than 45. 5 times 0 is 0, 9 times 5 is 45, and again, 45 is not less than 45. So D is not a solution to the inequality. Choice E. 5 times 0 plus 9 times 9 should be less than 45. 5 times 0 is 0. 9 times 9 is 81. 81 is not less than 45, so E is not a solution to the inequality. choice F. 5 times 5 plus 9 times 9 should be less than 45. 5 times 5 is 25. 9 times 9 is 81. And 25 plus 81 is 106, which is not less than 45, so F is not a solution to the inequality. Our final option, 5 times negative 5 plus 9 times negative 9 should be less than 45. 5 times negative 5 is negative 25. 9 times negative 9 is negative 81. And negative 25 minus 81 is negative 106, which is less than 45, so G is also a solution to the inequality. So A, B, and G are all point pairs that are solutions to the inequality. If you have any questions about how to solve this practice problem, please use class time to ask for further clarification before we move on. Our next practice problem says, consider the linear equation 2y minus 3x equals 5. The pair negative 1, 1 is a solution to the equation. Find another xy pair that is a solution to the equation. So looking at the equation that I have, I know that if I put 1 in for x and 4 in for y, then I will have 2 times 4 minus 3 times 1 equals 5. 2 times 4 is 8. Negative 3 times 1 is minus 3. And 8 minus 3 equals 5. So the point 1, 4 is another solution to the equation. Number 2 asks, are negative 1, 1 and 4, 1 solutions to the inequality 2y minus 3x is less than 5? Explain how you know. So for the first one, negative 1, 1, that means we would have 2 times 1 minus 3 times negative 1, and that would need to be less than 5. 2 times 1 is 2. Negative 3 times negative 1 is positive 3. And 2 plus 3 equals 5. 5 is not less than 5, so negative 1, 1 is not a solution to the inequality. Now we can check the other point. 4, 1. That gives us 2 times 1 minus 3 times 4. 2 times 1 is 2. Negative 3 times 4 is negative 12. And 2 minus 12 is negative 10. Negative 10 is less than 5, so the first point is not a solution. The second point, 4, 1, is a solution. And number 3, explain how to use the answers to the previous questions to graph the solution set to the inequality 2y minus 3x is less than 5. What they mean is the points -1, 1 and 1, 4 make the equation true, and can be used to draw a dashed line boundary and since the point 4, 1 is a solution, 4, 1 can be used to shade the correct side. So when you are trying to draw this graph, you would plot the points -1, 1 and 1, 4, then draw a dashed line through those points. That will give you your boundary. Then you will plot the point 4, 1, and whichever side of the dashed line that point is on, that is the side that you would shade to show the region of solutions for this inequality. If you have any questions about how to solve this practice problem, please ask for further clarification before we move on. Our next practice problem says, the boundary line on the graph represents the equation 5x plus 2y equals 6. Write an inequality that is represented by the graph. So the first thing to notice is that it is a dashed line. That means we are not including it. So we only want to know, should we change the equation to a less than symbol or a greater than symbol? To determine this, we can choose any point in the blue shaded region. The easiest point to use in that region is 0, 0. So if we plug in 0, 0, then 5 times 0 plus 2 times 0 becomes 0 plus 0, which is 0. We know that 0 is less than 6, therefore the inequality should be 5x plus 2y is less than 6. Every point in the blue shaded region will make this equation true, or this inequality true. If you have any questions about how to solve this practice problem, please use class time to ask for further clarification before we move forward. Our next practice problem says choose the inequality whose solution set is represented by this graph. The first thing to notice is that there is a dashed line. When you see a dashed line, the only acceptable inequalities are less than or greater than, because we are not including the line itself. So right away, we know that B is wrong, and we know that D is wrong. Now, in order to figure out whether the answer is A or C, we can pick any point pair in the blue shaded region. Again, the easiest one to use is the origin, 0, 0. What you do is you plug 0, 0 in for x and y, and you see what inequality is true. So this means we would have 0 minus 3 times 0. That becomes 0 minus 0, which is 0. And we know that 0 is less than 5. That means choice A is correct and choice C is wrong. If you have any questions about any of the practice problems that we have gone over in this lesson, please use class time to ask for further clarification before we move forward to lesson 22.